I think anywhere up there is fine.
Should we check that? Yeah, she took this up from school. Just like taking some classes. She that's what we were. Yeah, so she's
Okay, my questions are all up.
Yeah, we met at Mobile Monday that you were. That must be it. Yeah, at Harvard Research.
Yeah, exactly.
All right.
That's it, like 4 years ago.
Yeah.
So, 5 minutes. So you can see it.
Hey, how's it going?
Pretty good. How are you? Too bad, thanks.
And thank you for selling contacts. And what we ended up doing was like,
Hey, what's going on? Excellent. Hard
Welcome
things.
to space.
Yeah, thank you.
You've been here for 2 months now, right?
Coming up on 2 years.
Yeah.
Okay. Do you have a microphone plugged in or not?
Yeah, sure.
Okay. Anybody have a fork and a glass in the kitchen?
Should I do it? Okay. Oh, you got it already. I used the wrong.
Oh yeah. Hold on.
Uh-oh.
Hey, there we go. So thank you so much, everyone, for coming. This is the first time we're doing lightning talks. My name is Brett Rays. I'm slurring my speech because I went to the dentist, not because I'm breaking too much. Just wanted to make that clear to everyone. Thank you so much for coming. We have, I think, eight or nine lightning talks. This is the first time we're doing it, so we thank you for coming. We are going to be streaming this live, so we have a tweet on the Rays Labs account. If you can retweet that so more people join and we have a better event next time, that would be awesome. This is Michael. He's going to be going up first, and I'll let him get started.
Hey. My name is Michael. I'm lucky enough to manage the native software engineering teams here at Rays Labs, Android and iOS. And I'm lucky enough to work with some really smart people. We build, or at least try to build, like you guys do, awesome apps. And we write a lot of code. We try to make it great code. Hopefully it often is. And this is an event we wanted to hold to sort of share what we have learned in the process. A lot of it is iOS 8 specific, some of it is not. So I hope you enjoy the talks. If you have questions, we're going to be moving the talks along. So if you have questions, please come ask me or the speakers after. There'll be plenty of time for that. And meanwhile, first to start is Nick B. talking about custom keyboards.
All right, hey everybody. My name is Nick Kwanatakis, developer here at Rays Labs. So today I'm going to talk a little bit about iOS 8 custom keyboards. So first I'm going to talk a little bit about what custom keyboards actually are. Then I'm going to talk a little bit more about what you can do with custom keyboards. Follow that up with a little bit more information about how to actually create one of these things, configure it, so on and so forth. Also some information about the containing app, the keyboard's actually part of, and then wrapping up with some information about gotchas and gimmicks, sort of things you might want to know that you might not know from the doc. So first of all, what is a custom keyboard? So custom keyboards, app extensions introduced in iOS 8. Basically, it is a discrete binary that you can actually use to override the system keyboard. So in this case, this is a keyboard called SwiftKey. So someone can download the SwiftKey app, it exposes the SwiftKey keyboard, and then the user can then select it as a keyboard option anywhere in the system where text input happens to be. So you tap the little globe on the bottom of your screen, of your keyboard, and it will flick through the various keyboards that you have. So what can you do and what can you not do with custom keyboards? So on the left here is things that you can do. So you have access to all of the friendly Objective-C frameworks that we've all come to know and love, UIKit, Foundation, so on and so forth. You can do any kind of view drawing that you can do in regular apps, so just standard view hierarchies, auto layout, so on and so forth. You can access the user's location, you can get internet access, and you can even access text that they've already inputted in whatever field they're doing, and I can talk a little bit more about why that may be useful later. But moving on to things that you can't do. So you cannot draw outside the bounds of your keyboard. So anything that Apple does where they're drawing inside the text view for autocomplete and that kind of stuff, you cannot do with a custom keyboard. You can't reach into an app where the keyboard is being used, so you can't get a handle on the text view, for example, in the SMS app to do whatever you want, attach images, that kind of stuff, not possible. Keyboards are very resource constrained, so you cannot use an excessive amount of memory, the system will kill you. Basically, they want a maximum amount of reliability. And keyboards can't run in the background like other types of apps can, so don't even try. So this is an example of a keyboard. So how do you create a keyboard? Basically, you create a target in an existing app or a new app, and then you configure the keyboard. You basically build your view hierarchy. And you have to subclass UI input view controller, and then you simply interact with a text proxy when you want to actually push text into the view or read text from the view. So in this example, this is an app that I've been working on where it will take the text that you've already entered and present you with a list of emojis that actually match whatever that text string happens to be. So this is all via the text proxy. Containing app, so like I said before, every keyboard has to come in as part of the containing app. So this is the app that you install, and then the keyboard becomes available within the settings app of iOS. So some interesting things you can do with the settings app is via something Apple calls app groups, you can share data between apps and extensions. So things like user defaults and file data you can share. So in this case, I'm using the container app to configure a theme that gets applied to the keyboard. So that brings me to my next point about gotchas and gimmies. So one thing to remember is, in order to do any of this interesting sharing stuff, you have to enable full access when you actually configure the keyboard. This is a horrible user experience that Apple has put forth right now, because basically you add the keyboard, and only after you explicitly drill in do you see that switch as a user. So it's something that's very important that you tell your users when they actually open your app. This is what you have to do in order for the keyboard to be functional at all. Mind the review guidelines, because there are a lot of very strange things that Apple requires of you for a keyboard. They're very strict about what they do and don't allow. Provisioning, everyone's favorite. I'm happy to tell you that you're going to be doing a hell of a lot more provisioning if you do keyboard. So every extension has to have a discrete app ID, just like an app. You have to configure app groups in there. It's a lot of fun. I love it. It's great. And then there is no state restoration in keyboard, so just keep that in mind again. If you go out of the keyboard and you come back in, sometimes shared memory will be maintained. So if you have data structures and singletons and that sort of thing, they will, but your views will be torn down and rebuilt. So just to recap a little bit what I talked about today, just what are keyboards and sort of what kind of things can you do and can you not do. A little bit of info about how you set one up and containing apps, and then some gotchas and gimmies. So hopefully this was a little bit of a primer for people that actually want to dive into this stuff, and hopefully save you a little bit of time too. So thank you.
All right. Okay, so next up is my first part of a two-part exciting doubleheader about interface builder. It will be Zev and interface builder master Zev and B. So we're going to talk about two important new features that have come to IB in XCode 6. And they're called IBDesignable and IBInspectable. And they really changed the relationship that many of us have with interface builder as a tool. Here we go. So the main problem, interface builder has some issues, I should say. The main problem that we found is that oftentimes you just can't see what you're doing. So you're over here setting up a complex hierarchy of views, and you have some containers, and you have a navigation, and you have some stuff, and you can't see anything. Why? Well, because they're all white. And you haven't put things in there yet, and you can't do layout properly like this. What you really want is something a lot more like this, so that you can see what's going on. And we'll try to help you make this happen. So the second major problem we found is what I call theming confusion, which is that your app is full of colors and fonts and images and sizes and metrics and other information that needs to sort of be standardized and determines how your app looks and feels. And you have two choices with this information. You can configure it all in code like this, which is sort of wordy, but you have a lot of flexibility. And you can standardize information. You could make it declarative. You can do any kind of interesting things. Or you can put it in IB. So if you don't put it in IB, it looks like this. On the other hand, if you do put it in IB, all these colors and fonts and sizes begin to spread throughout your app. They're not in one place. You can't standardize them. You can't control them. And you can't make them declarative. It's a real pain in the ass. And we found that this is a real maintenance problem over time. So what is IBDesignable? IBDesignable is a tool that lets you draw custom views that you've written in Xcode inside Interface Builder. And views can even be drawn differently in design mode, or they can be drawn in design mode exactly the same as they would draw at runtime. And auto layout information comes through. So things like intrinsic sizes. If your view calculates and sets an intrinsic size in code, that comes through. And that dramatically eases working with auto layout in interface code. How do you do it? Well, you start by putting your views inside a framework, which means you need to create a framework target and add your views there. You need to remove your views from the apps target, because if you don't do that, you're going to get collisions and classes implemented in two places, and that causes linker warnings. And you need to make sure to expose the headers. which means the .h files for those views need to be set as being part of the framework target and being exposed there. And then, most importantly, you need to mark up your UI view subclasses, like so. All you need to do is put IBInspectable before the end interface, and interface builder will begin working its magic. So how does it work under the hood? Basically, XCode runs an instance of IBTool. IBTool loads your framework dynamically from the compiled framework file. IBTool renders your view into an image. IB shows it to you in the designer, and, which is very important, IBTool actually stays running, reloads your framework when your code changes, and responds dynamically to changes that you may make, so that you can quickly iterate on your views. So why do you care? Well, complex views, complex ZIBs that have custom views now actually become sane to work with, instead of just a bunch of white boxes that are uncontrollable. You can rapidly develop and tweak your custom views. You can change something in code, and rather than having to rerun the entire app, you can see those changes immediately, which is a huge improvement to sort of the cycle that we all have to deal with. Number 3 is there's a lot less need for placeholder auto layout parameters. Because intrinsic sizes and things come through, auto layout looks in your design mode much more like it'll look at runtime, and that is a major improvement. And of course, ZIBs become readable, which means that, like good code, you 6 months from now can come back to it and use it, and your future successor can do the same. And it just makes so much more sense than it used to before. So, what about theme? So that solves the first problem that I talked about, but what about the second? So if we have a view like this, we probably want to control this text and control these colors. And sometimes we want to do that from within IB. So how can we control that from within IB but still get the benefits of centralizing this theming information that I was talking about? Well, that's where the other part of this comes in, and that's IBInspectable. IBInspectable lets you define parameters for your custom views to include inside interface builder. It's effectively the old user-defined attributes feature that IB has always had, plus some awesome user interface on top of it. And it has support for colors and strings and numbers and booleans and images and actually some other stuff that I'm not even mentioning here. And the important thing is that rendered views update in real time when you change properties in interface. Because IB2 is sitting there running your code, re-rendering your view. And again, that does wonders for the cycle of development as you need to change colors, metrics, fonts, and sizes. How do you make it happen? Well, all you need to do is mark your property to be IBInspectable. And then you are able to set properties inside interface builder in the inspector right here, and there's custom UI for many of the types that it supports. So that was pretty theoretical, but the second part of the doubleheader is coming up, and that will be a set of examples for how we can smartly use these technologies to build Cocoa apps better and faster. Welcome, Zach. Thanks.
So Michael and I have been working on an app together, and how does this work? And these are some things that we've developed and are continuing to evolve. We hope to open source some of these at some point. So these are some of the tricks that we've come up with to make working with IB a little more palatable. So the 3 things I'm going to talk about are Hairline Loops. You'll see this coming from designers a lot with some of the iOS 7 inspired UI trends. Placeholder Views, which you saw a little hint of, and how we set up the theme labels. So here's a comp that I got from a designer, and I want to zoom in and look at these things right here, these hairlines. Now these things are annoying because they need to be 1 pixel. They're specified as 1 pixel wide, and that means they're 1 point wide on non-Retina devices and half a point wide on Retina. And then as we get into 3x and other things, it's going to get more and more complicated. Wouldn't it be nice if those just did the right thing? You just put them in IB. They also need to be some color, and they're kind of muted, so wouldn't it be nice if in IB they were a bit stronger and you could see them. So we want something that automatically constrains itself to be 1 pixel wide and is the correct 1 pixel on Retina and non-Retina, has some default color, and has a placeholder color that you can use while you're designing. So we make a subclass of UI view. We specify it as IB designable so that it will draw in IB, and we have a property for whether or not it's horizontal. And we have a line width property in case you want to change it. We make both of those inspectable so that they will expose setter UI in Interface Builder. In intrinsic content size, we figure out what's the right line width. So we're dividing one by the main screen scale to figure out if it's going to be 1 point or half a point, and then returning an intrinsic content size based on whether we're horizontal. So you set whether it's horizontal, and then IB just figures out that it's supposed to be 1 pixel in this dimension and whatever size you set in the other dimension. And prepare for interface builder is a special method that is only run in IB, and so we're just setting the background color to red so that you can see it. And what we end up with is this. So they show up red, but they don't show up red in your running app, so they're really easy to see where they are and how the spacing works. And I should have put in a slide for the constraints, but this thing is constrained to this and maybe constrained to these, but its width is not constrained. It figures out what its own width is supposed to be. So that's been really useful. You can just throw them in and put them where you want. And this is what the properties inspector looks like. You get a little menu for whether it's horizontal. You can set the line width. If you don't set it, it uses the default value. So placeholder views, which Michael had showed you briefly, are really useful when you're doing view controller containment. I think it was added in like iOS 6, where you can net view controllers, and it makes it nice to build your apps in a composable way. But if you're designing composable view controllers in IB, you end up with this big white thing with maybe a toolbar and then a big blank area, and you're not sure what you're going to put there. So this makes it so you can label and color your placeholder views so that you can see what's going to go there. So we've got a placeholder view that has a placeholder color, a placeholder title, and whether or not it's going to draw at runtime. And so you get the labels. You can label them. You can set the color. You can see there's a hairline that we're using also. And this draws at runtime. If you're building this and you don't have content put in there yet, you just check on draws at runtime, and then while you're working, you can see exactly this. It'll show the green with the label. And then when you're done, when you've got content to put in, you just uncheck that. It stays like that in IB, but it goes away from the running code. And if you're ever needing to debug something, you just turn it back on. It's always there when you need it. And finally, theme labels. Here's another comp I got, and it's got all these labels. Like these ones are the same font. These are maybe the same size but different colors. How am I going to specify this? So we have a theme label, which is a subclass of UI label. Oh, hang on. Yeah, so this is if you leave it out and then do it in code, you end up with code that looks like this, and a zip that looks like this. So neither of these is really nice to look at or easy to maintain. So we have a subclass of UI label that has a selector property for or a string that is the name of a selector for the custom font and the custom foreground color. And at runtime, we're going to look those up. And we have a big file that's just a bunch of methods that all return a font. And so we specify them up here. You just put in the strings. Notice that I'm not changing the default color or font of the label. They stay as they are in IB, but it still picks it up. So I've now put in those properties. It's figured out that the size from the default label is different because changing the font of the label, even through an inspectable, still knows that it picks up the intrinsic size. So XCode is telling me that I need to resize my label. And we've set it up so that if you make a mistake when it's looking up the method, if it doesn't find that method, you get orange and purple Comic Sans. You can tell immediately that you made a mistake. Come find me after if you want to talk to me about any more of this in detail, because there's some nifty tricks that we're doing to get this to work in our project. So that's IB designable for views that render live in IB, and you can use it to do all sorts of cool custom controls. Anything you stick in there will render. IBInspectable, so you can edit properties, and there's some properties that are not supported for editing yet, but on file radars, hopefully we'll get those. And then 3 examples that we think are kind of cool: hairline views, placeholder views, and theme labels. And if you want to find out more on how to set this stuff up, including the framework stuff that Michael talked about, check out WWDC 2014 Talk 411, What's New in Interface Builder. They go through all the process of doing all that stuff. So try it out. Maybe you'll get to like IB again. Maybe.
Thank you, Zeb. Next up is John Stricker talking about Mantle.
It's over there. It's just resting on there, so you can pull it off.
Oh, is it? Oh, nice. Sweet. Hi, John Stricker. I'm a software engineer here at RZVinyl. And I'm going to talk to you today about Mantle and OpenGL. I had some experience with OpenGL. And today what I'm going to do is just walk through some comparisons between these two APIs. Also to give you a bit of an overview of Mantle, in particular how it compares to OpenGL. And then I also have a second part of the talk which will very briefly talk a little bit about computing in Mantle. So one of the things I'm going to walk through here is this rendering of a box. This is just a basic cube. It's got 16 faces on each side. This is being rendered right now in OpenGL. So the dub this year was really amazing, right? So they dropped the metal bomb kind of softly, and we were kind of thinking, wow, could this be, at least I was, maybe this is an alternative to OpenGL. Maybe they're going to replace OpenGL. This is huge. And then they went right ahead and announced Swift, and then everything was a blur. So, yeah, I mean, it still is a big deal. If Apple wanted to get into 3D APIs or hardware accelerated APIs, it would be amazing. They would be able to really do a lot of things because they have control over the whole stack. So you might worry about two things if you're going to make a hardware API. One is market penetration, making sure a lot of different devices can run your API. Apple doesn't care about that sort of thing, right? So in terms of control, you've got OpenGL where you don't know what the CPU is, don't know what the GPU is, don't know what the operating system is, don't even know what IDE people are going to be using. DirectX, you can know the operating system, the IDE. Mantle is a new API developed by AMD, and people will say in response to how slowly developed OpenGL and DirectX have been lately. Mantle only works for AMD GPUs, so basically they have control over their hardware, but that's it. So again, with Mantle, you get check marks across the board because Apple controls all of these things. That means that no matter what else they do, they're probably going to get the best performing API because they can control the hardware and they can control the software. So for all of these new APIs like Mantle and like Mantle, and also what's coming down the pipeline in OpenGL, the main thing that they all try to address is this bottleneck of the CPU. GPUs are fine, they're awesome, they perform well. We're not worried about them throttling down our systems. The problem is the CPU is lazy, and it takes forever to talk to the GPU. It takes forever to take things over to the GPU. It takes forever for the CPU to translate things into code that the GPU can understand. It has to compile shaders. It has to validate whatever commands that you're trying to send over to the GPU and translate them. And then it's got to process and move data to the GPU, which is also costly. This is all taking up CPU time. So you're going to see in these advanced APIs, they're going to actually try to address the bottleneck. So I'm going to move on to the example I'm using today, which is the data itself, which is this cube. This is basically just the cube that you're seeing spinning here in OpenGL and Blender. And I'm going to show you how I was approaching this both in Mantle and OpenGL. So let's start with the shaders. So this is the vertex and fragment shaders that are being used in this OpenGL program right now. And you'll see with the OpenGL shader, you basically have attributes, varying, and uniforms that are defined up here. Attributes are what's coming into your vertex shader. Variants are things that are passed between the two shaders that you're using, and the uniforms are things that are kind of like global constants. These are things that both shaders may access. This is fine. You have to laboriously define all of these in your own code, basically, as you're setting up the shader itself. And you also have to take careful note of the indexes of each of these variables and record those sorts of things because you have to reference them later on in your code as you're assigning values to them. Inside the shaders, it's kind of normal code. You don't have as much power as, say, you might have in C++, but you can do quite a bit with GLSL. So if we move to a metal shader, there's a couple of things that are pretty awesome right away, which I didn't quite point out on the OpenGL shader. You'll notice that the vertex shader here and the fragment shader here, they just say main. You're not passing things in. And you're not seeing what actually is coming out. What's coming out are these magic numbers like GL position or GL frag color. You just need to know those sorts of things. And that's where the GPU itself is going to pick up on those values as they're being passed out. If you go to a metal shader, so you're actually going to be passing values in, just like a regular old function. You're actually going to be returning values, and you can specify what those values are. And you can have whatever value you want going into your fragment shader, for example. So it starts to feel an awful lot more like you're actually writing real C++ code. And Mantle shading's language itself is actually built on top of C++ 11. The things where you'll see magic numbers here within the shaders are these. You'll see these double brackets. This is a feature of C++ 11. These are accessors. Basically, this is a way of identifying sort of the locations of this data that you're going to refer to in your own code as you're sending data back and forth to the shaders. So, for example, the vertex array is going into buffer 0. So, GL shader setup. There's a couple things you got to do. The shader files themselves, as they sit, let's say you're using Xcode, they're just assets. They're basically like images as far as Xcode is concerned. You just copy them over. You got to compile them. You've got to load them first, compile, then you got to configure them. You got to set up where all the variables are and what indexes are related to all those variables, and then you got to link those. There's about 200 lines of code that it takes to do this. A lot of it's boilerplate. It's pretty common to be able to mess with shaders like this at this point, so it's not like there's any mystery to it, but it still can be pretty tedious, and if you have a complex shader, it can be a pain. Plus, you're going to have some slow down at startup when you have to compile and do all these things to your shader. This is Mantle shader setup. You just say, give me the default library from the device, and the fragment program, it's called this, and vertex program, it's called that. And you have your shaders. It's very nice. So buffer prep. So with OpenGL, you basically have to generate, well, if you're doing things right, or at least more right than others, and there are probably even more right ways to do it than I'm showing you here, I'm sure. But you generate what's called a vertex array object. You're going to bind it. You're going to generate all the buffers within that array object. You're going to generate a vertex buffer object within that, and then you're going to enable all of the vertex attributes, which are going to tell this vertex array object how the data is laid out within itself. So you're going to do all that to set up the buffer itself. Mantle, you just say, hey, give me a new buffer. Here's the array. Here's how big it is. And that's some options. That's it. So it's very nice. Drawing. So when you draw up here, you got to go through all of your state changes. If you're enabling or disabling depth tests, you need to worry about that. So there's a lot of things that you have to do in OpenGL where you worry about the state of the system because it's very costly. If you send a duplicate command over to the GPU, it slows things down. So you have to take into account state, and then you have to set up all your shader stuff and so forth, whatever the different settings are. You got to pass the information over. You got to bind the vertex array, then you bind the texture, and then you draw the array. And in the middle, you say draw. So Mantle is easy and it's awesome, and we all should do it, right? And basically what I'm doing here is I'm hiding all the really nasty parts about Mantle from you. This is where Mantle gets hardcore. The thing is that in terms of how it relates to how you normally might do something in OpenGL, Mantle is easy and it's really streamlined and it's awesome. But Mantle has been designed to approach the CPU problems that I was talking to you about earlier. And in order to do that, you actually have quite a few levels of complexity, which I actually am not going to have time to go into this talk. But I wanted to show you the great parts about Mantle, which is something if you were to start diving into Mantle, you might not get to see those parts. You'll start here and get lost. But just to summarize briefly, because this little box tells me how much time I have, basically the idea is that you're going to have a series of render command encoders. You might wonder, where did that render encoder come from? Well, you're going to set all of that up. Basically, you're going to package all of this stuff up. What's the texture? What's the sampler state? What's the depth stencil state? All these different kind of pipeline states, basically. You're going to be able to package that all up, and it's going to be tested and compiled, more or less. And then you can send that into a command buffer, and then you can just fire it off. And you can do that with different command encoders. Setting these things up is a bear, and it's confusing. So I don't have time to talk about that. I don't claim to understand that completely yet. But it is awesome. So if you were going to jump into Mantle, I have some tips for starting out. Don't be tempted to do this in Swift. Okay? I did, and you'll start writing a bunch of math libraries, and Mantle's native language right now is Objective-C++. Swift can't handle some things that Mantle uses right now in terms of some of the math libraries that are being used. But also, it just creates way too many points of confusion. The shader language is not going to change anytime soon. It's always going to be a variant of C++. I'd be very surprised if Mantle's shading language is going to move over to Swift. But it's very interesting to think about these two groups that we're working with in Apple. One doing Swift and one doing Mantle, and I wonder if these guys are talking to each other at all. But the point is, too, for Mantle, their target audience right now is really hardcore graphics engines. And the language of choice for such engines is C++. Watch out for coordinate systems. Metal uses a right-handed coordinate systems, and sometimes I forgot that. There is this pretty good sort of control scheme that's set up within a lot of the Apple example projects that you'll see, where they'll have a view controller and a view, and this pattern works really well, and all you need to worry about is the renderer. So if you grab Apple's projects, don't worry about the view control and the view. Start with the renderer. That's where all the magic is happening. Don't be confused by constants versus uniforms. Metal language, for whatever reason, they call uniforms constants within the shading language. It makes some sense because uniforms sort of stay constant as the fragment shaders, the vertex shaders are cycling through the data, but it's confusing because we have other uses for the word constant. And then watch out for magic. Some things magically happen in Metal, and I just didn't know it. I spent quite a lot of time trying to figure out how the hell the vertex shader can actually know the way the data is organized, and the answer is that it just does. It just can figure it out. You just send it there, and it just works it out. It's awesome. All right, I spent my 10 minutes on that, so I'm not going to have time for the compute talk. But just to show you that I actually was able to pull off a little bit of Metal here. It's not going to be upscaled very well, but this is just taking that basic cube and running it through some Metal shaders. Basically, 80% of this code is Apple's demo code, really. But you can do some awesome things with this API. I think even if you don't end up using it directly, it's going to be a big win for Apple. So thank you.
Next up is Adam Howard, talking about Touch ID.
I don't know about you guys, but this is not Metal. Alright. Hopefully some of you know the song that this title references, but I'm going to be talking about iTouch. Touch ID. It's something that we've used lately on a recent project. I wanted to share some of the stuff that we've been doing with Touch ID. So I'm going to talk about when you can use Touch ID and how you can use it. I'm going to talk about some of the things that you should be aware of, like states to catch, and then I'm going to talk about the suggested workflow for login. We went through a few rounds of design ideas as to how to make this work. We think we have a pretty good idea as to how to use Touch ID in an app, so I wanted to share that with you. And then talk about a consideration if your app supports things like multiple accounts. So Touch ID. There are two basic ways to incorporate Touch ID into your app. The first is local authentication. I saw my first example of this with the Mint app. I don't know if anybody uses Mint, but they used to have just a simple passcode that you would enter, where you enter a 4-digit number to unlock the phone. The idea of that is that just to say, I own this device, and that's what local authentication is basically supporting. It's a way of saying, I own this device, let me into this app, and let me see my bank account or whatever it is you're looking at. The second kind is Keychain Touch ID. So this is where your keychain, you have user secrets that you're storing, and you want to protect them using the Touch ID mechanism. Things like passwords could be, you can secure anything in there. So if people have things like social security numbers, it's all stored in the secure enclave. So these are the kind of things you want to protect and keep them very, very secret and only to the user. When you launch Touch ID, you're going to see a dialog like this. You have control over the text in the middle. And then because when you're accessing the keychain, your only fallback option is to either cancel or to be able to fall back to the passcode, which is a pretty terrible fallback in that it's a 4-digit number to be able to access your top secret social security number right now. So some of the error states that you're going to encounter are, what if you don't have any fingers registered? You might have Touch ID turned on, but then you've deleted the last finger that you had enabled. People do crazy things, and deleting all their fingers to try to disable Touch ID are things that I've seen happen. And I know that it's just something that you have to think about and incorporate that into some of the error states that you're handling. The next one is no Touch ID device. Why isn't this working on my 3GS? Well, this is an old device, but sometimes when we get excited about new technology, you're trying out the new APIs, you forget about the fact that your code has to work on the 3GS that your mother owns. And then passcode deleted. One of the key things about using not the local authentication APIs, but if you're trying to use the keychain specifically, if you delete your passcode off your device, your keychain, as long as
the way Apple recommends setting it up is that you say that no passcode, that you have to have a passcode set. So if you delete the passcode, you lose all your Touch ID credentials. So it's just something to be aware of, that if somebody deletes the passcode because they're fed up of typing 4 digits in or trying to unlock the phone with their fingers, that you'll lose that, all that convenience of being able to log in very quickly. So the suggested login flow, these are some screenshots of an app that we're working on right now for B&H Video, B&H Photo, based in New York. You want to start off presenting your regular login flow, and then if you detect that you have Touch, to detect if you have Touch ID available, the part of this code that really does the business is this line here, the can evaluate policy. You set up a context for local it uses the local authentication API, but to get context, but then you use this context can evaluate policy, and you say you want authentication with biometrics, and it will tell you if Touch ID is available. All those error states that I mentioned on the previous slides are all caught by this. So then you have to have your error handlers respond to that. And throw some really obtuse error code numbers that you then have to catch and write your own switch code for. The next thing is, if you do have Touch ID, once you've logged in, present what we like to do is this kind of a screen that, instead of presenting a stock dialog or using the UI alert view, is something that looks pretty and describes to them in a bit more text than just like 3 lines of text and a yes/no button, and give them some better options like, do you want to log in faster? So trying to make the experience for the user a little bit more comfortable. And then to actually present the Touch ID, the next time they come to log in, it's just this simple sec item copy matching line of code. All this code will be available after the fact if you want to get your hands on this, by the way. But that launches the Touch ID if Touch ID is available on the device. And then if one of the fallback options, you saw that there was enter passcode was one of the fallback options. This is what you'll see. So just watch out for this, because if you have too much text in the reason why you want people to use Touch ID, why you're telling them what they're authenticating for, so to log into this account, the Apple engineers didn't quite finish this screen yet, so it's not very pretty at all. And then once you have success, show them a nice friendly message, let them know that they're logged in, and handle failure. It's important to know that you want users to log into your app ultimately, or to do whatever it is they're doing in the secret, so give them a fallback option if they're not able to do it. And then the last thing to talk about was just multiple account cases to think about. Do your users often have 2 accounts? So one user with 2 accounts, maybe you have a work email and also a home email, so those 2 separate accounts. Thinking about that means the way you architecture your Touch ID implementation has to change to recognize the fact that your one fingerprint is going to unlock 2 accounts if you want it to work that way. The second thing to think about is also if someone else logs into your phone, I don't know, a lot of people do this, but like, can I just check my email on your phone, and they log in and they use your Touch ID, and suddenly they're looking at your birthday present orders that you've just placed for them, that kind of thing. So that's it with my whirlwind of Touch ID. I told you it wasn't quite as challenging as Mantle. My name's Adam Howard. I've got my details on here. I'll be around for the rest of the evening. Let me know if you have any questions you want to talk about.
Next up is Zeb talking about the interface builder inspector.
It's going next. I didn't switch. Yeah, all right. Live code demos. This is exciting.
Gets more guts than the rest of us.
Is this sharing correctly over the Hangout?
Yep.
All right. So I want to talk about the visual debugger. We good? Okay. I'm going to talk about the visual debugger in XCode 6. This is a new thing. If you've used Reveal, then this will look familiar. It's better in some ways, worse than others. But I've been using it a lot recently, and I think it's pretty nifty. So here's a little sample project. And if I run it, you should see there's a problem. I'm expecting there to be an image in between these 2 labels. It's not showing up, and I don't know what's going on. Is it a layout issue? Maybe the image is missing. I'm not sure what's going on. So if I click this little button down here, let's see. We can see if I can zoom in here. There we go. So that's the button. Is the Where's the tooltip? No tooltip. It's the visual debugger. So if you just click that button, the way it works is it basically breaks in the debugger, and then we've got this view here. We can rotate it around, pinch and zoom, see the different elements in our view hierarchy. You can see up here is they're using the jump bar to expose that hierarchy, so I can see here's that label. It's got a sibling that's image view. Okay, so I know my image view is there, and if I select it, I can't see it. Now let's see what the problem is. If I come over here to the inspector in the sidebar, unfortunately I can't make this bigger, but maybe I can zoom in. Okay, here we go. So I see that it's an image view, there's its address, and I can see that it's got no image. Well, that's weird. I'm expecting there to be an image, so maybe I should go look at my code. Yes, good old chemming. There's a typo there. So now if I... Chemming is when you bad kerning. Anyway, there we go. So now I'm getting the image that I was expecting. There's one other cool thing I wanted to show you about constraints and the debugger, which is that in iOS 8 they added a property constraint and a layout constraint called identifier, which is cool because you get these printouts. So I'll show you. If I break in the visual debugger again, and I've got this view here, I can copy its memory address. And can you see the debugger? I'll maybe zoom in a little bit. If I PO that view's constraints, there's a lot of constraints, and I don't necessarily know what all of these are. I didn't necessarily create all of them. So if you're building I want to set identifiers on things, they don't expose it in IB. Identifier in IB, except you can. You can do it using custom runtime attributes. So if I select the constraint here, see I've got it selected, and over here in the identity inspector, you can add a new identifier, make it a string, and we'll call this my awesome constraint. And then if I run this again, unfortunately it doesn't show it if I break in the visual debugger and I go and find that constraint. So that's going to be this label. If I go over here, there's the basic information inspector and then the size inspector. You can see the constraints that are on this label, and I can see that it has its top is pinned to the image view bottom 17, but it doesn't actually show me. Even if I go over here and find that particular constraint, it doesn't tell me the memory address or really that much useful information. But what I can do is if I take the whole view, grab its address again, and PO its constraints, you can see now we should have somewhere in here an awesome constraint. So it is showing, even though it wasn't really happy about letting us set that. Once we did set it, it does actually show it when you print out a constraint. It shows up in the description. So that might be useful for certain cases when you want to debug stuff. So that's just a quick little bit about the visual debugger in case you hadn't seen it yet.
Next up is Joe Howard talking about enumerations.
Hi, I'm Joe, talking about enumerations. So first, I'll start off by talking about why I talk about enumerations at all. They seem pretty pedestrian. We'll talk about some of the basics, compare Objective-C enumerations to Swift enumerations, look at some examples from the Swift book, and then I'll walk through a real-world example, and then finally try to answer the question, can we write better code with Swift enumerations? So first, why talk about enumerations? They're a pretty basic part of Objective-C. So one reason would be because they are, pretty easy topics to talk about. Maybe we could talk about them in a complete way in a lightning talk. But also, in Swift, it turns out they're really not that pedestrian necessarily. I pulled this chart from a talk that was given out over the summer at an NS meetup meeting. I don't know if I necessarily agree with this chart entirely. So on the left, there's parts of Swift that haven't really changed much from Objective-C, just really syntax changes. In the middle are items that have changed, a little bit in Swift from Objective-C, and on the right are items that are kind of completely new. And so the person who put together the stock identified enums as being something that are very new in Swift. So that makes them kind of interesting on their own. Okay, so now some of the basics of enum. So I'm sure everybody here is familiar with enums in Objective-C. You would write one with using the enum macro. They're backed by an integer type, passing an integer type. They're really just kind of an alias for integers. In this case, for direction, I'm using the NS integer. A best practice in Objective-C when you're defining enumerations is to use the name in each of the values. And then if I make an enumeration, say north, that value is actually set to 0. So if we look at Swift enumerations, the syntax is a little cleaner. Because of strong typing, we can get rid of the best practice of using the name of the enumeration in the values. And also, it's a real type. It's not, in this case, by default, backed by an integer or anything like that. So if I set a direction equal to north, it's not equal to 0 in this example. Okay, so now some examples from the Swift book, which I'm sure a lot of you have gone through. So here's a rank from a deck of cards. And here we've given it an explicit backing type of int. It doesn't have to be int. It could be any numeric type, float, double. It could also be a string. And then also in Swift, you can add methods to your enumerations. Here's a custom method that gives a string version of each value. And then there's also some built-in methods like toRaw, which will turn the enum value into its backing value. And I'll just note that in Swift 1.1, which was announced yesterday, this toRaw method is actually replaced with a property called raw value. Okay, one other example from the Swift book. In Swift, you can have associated values with your enums. So here's a case of a barcode enum, 2 different types. One of the types has 4 different integers associated with it, and the other one has a string associated with it. So I can create a barcode instance, and then extract those associated values in the case statements in a switch statement. Okay, now I'm going to move into a real-world example. This is a screenshot from one of the apps that RZVinyl has created, a really awesome app for B&H photo video in New York City. I think Adam showed the screenshot before. So I'm going to talk about this little greeting that we've got for users that are signed in. So I'm going to kind of walk through how I would do that in Swift. So first, I extracted from our app some of the code that we use for that greeting. I modified it a bit and kind of simplified it for this talk. But basically, we have a macro that has a nested ternary operator, and you pass it the hour of the day and a name, and you get out the greeting. So here in our viewAllAppear method, we are getting the hour, calling the macro, and we get a string value for our label. So how would we do this in Swift with an enumeration? So I started off by creating a period of day enum. 4 values: morning, afternoon, evening, and then a default of day. Then next, I gave it a backing type of string, and so each value has a string representation. It's the raw value. Next, I'm going to add 2 methods. So first, an initializer. So the initializer figures out the current hour of the day, and then sets the value of the enum based on that. And then a greeting method that takes a string and produces the greeting. So how would we use this in our code? So here's the Swift version of viewAllAppear, and it's very simple. We just create an instance of the enum by calling the initializer period of day, call the greeting method, pass the string, and we have our label. And just to show you it worked, I created an app in Swift, and that's actually the label from that method. Okay, so now let's compare the code between Objective-C and Swift. So in Objective-C, we had a macro that was using a nested ternary operator. In Swift, we have this type. The Swift code looks like it's a little bit more code than the macro, but I mean, we have this type now that we could use anywhere we want. Now in the client code, so if you imagine using this enum in an API, say, In the efficiency code, we first have to get the hour, day, and then call the macro. In Swift, we just make an instance of the enum, call a method, and we're done. So that kind of comes to the punchline of the talk, which is the Swift code better? Now, better is a strong word. I don't think we could say it's really better, but more maybe in terms of pros and cons. So it's the pros of the Swift code. Again, if you're looking at an API that had this enum in it, the client code is a little bit more concise. We don't have to calculate the hour. It's encapsulated. Also, if there are other parts of the app that needed to use a period of days, because there are business rules that needed it, I've got this nice type that I can use anywhere I want. So this is kind of the argument for object-oriented programming in a sense. And that's kind of really the point of enums in Swift, is that they're a full type now. They have more power with their backing values, and they have methods you can find in them. So they're really awesome, and I encourage you to use them. This is the only meme I could find on the internet about enumerations, so I can throw that in there. So, thank you.
Last up is Brian King, who will share with us his occult knowledge of testing.
All right. Forward. Hello, my name's Brian King, engineer here at RZVinyl, and I'm just talking about the test tooling that's available on iOS. This is an open issue in one of the frameworks that I'm going to talk about. Testing is not an iOS thing on iOS, and that sucks. You look at a lot of communities out there. Their testing is way better than our best practices or common practices, I guess you could say. So my hope with this talk is to really get people thinking about testing again and show off some of the third-party tools that fill in the gap that Apple has left open for us to fill. So the first thing is, if you've written a unit test, you've probably seen a line like this: XC test assert not nil. Stop doing that. You can do nice things like expect variable dot not to dot be nil. And it seems a little weird, but what that does for you is it automatically generates a usable error message and reads a lot nicer, in my opinion. The next thing is test layout. XC test is a little bit of a pain in the ass, especially when you have complicated test setup. You'll have a test object hierarchy with arbitrary setup, and then you get these great little test names that describe what you're doing. Like test that this works, and it's never sufficient, and it doesn't really document itself well. There's libraries like Specta, Kiwi, Cedar. There are tons of them. Use one, Specta. Specta is my favorite. And it gives you very nice formats like this. It's all block-based, and you can nest all of this arbitrarily deep so that as you get into more complex setups, your code becomes, or your tests become very maintainable, which is a huge value. Next up is mocking. The ability of Objective-C to mock is very, very good. Give it a shot. You can basically verify that something was invoked and stub something out to return a specific value. And this is great when you're working with libraries that you don't have control over, like core Bluetooth or external accessory. You just create fake objects very, very easily with these nice libraries. There's both OC Mock and OC Mockito. They're both very good. My favorite, and I think where there's the easiest payoff, is HTTP stubbing. Often we work with clients that don't have complete APIs every now and then. And these libraries let us develop code and work with them right off the spot. One of my favorites is Nocella, the one that had that bug logged, where you get this nice DSL. So I'll read it to you. It basically just says stub request post your URL with headers, and you get a little dictionary, and return your status code, blah, blah, blah. The cool part about it is that if you're running your unit tests and you have Nocella enabled and you make an HTTP request, it will throw an exception, and in that exception will be the code block to satisfy that. So you basically write your test, run your code, get the exception, copy and paste it, put it in your test method, clean it up a little bit, and you have that behavior sort of set in stone. The other library, OHTTP stubs, and there are a few others allow you to make more dynamic things. This is best for stubbing out specifics, not like creating a dynamic web server in your app that has any business logic. Integration testing is largely done with KIF. If any of you have experience with it, I would also like to talk to you afterwards, but it's a great way of sort of tapping and interacting with your app so that you can test a lot of things that are very hard to test, like first responder interactions or view will appear, disappear. This level of stuff is very hard to simulate on a unit test environment. So it shows a lot of promise. There are a lot of quirks with it that can be a bit of a challenge. And there are also these great additions that let you screenshot images and verify that the images are the same. UI automation, good luck. Frank, this allows you to write feature files which describe the behavior, and it sort of runs in a remote process. A great option for people that want to define their specifications very explicitly and have them execute. So that's about it. You know, I hope that you guys just try something new with testing. There's a lot of code in your app that can be tested well. If you want to do more unit testing and you're sort of challenged, I'll be around all night. Would love to talk.
So this was our first time doing Lightning Talks. What do you guys think? Good. Our developers and various people from Raise Labs are around all night. We have plenty of pizza and beer to hang out. Who is getting an iPhone 6? Just show of hands. Who is going to wait in line at Boylston Street with us tonight to get an iPhone 6? Come on. We got a couple people. Come on. So we're going to have a party out there. I can be like jog your memory. So thank you so much for coming out. Really appreciate it. Myself and anyone in Raise Labs, shirts, all the Michaels, all the developers are here. If you're interested in learning more about Raise Labs, come grab me. And thanks again. Appreciate it.